Assalamu alaikum. This is 12th chemistry, and our today's lecture is about the properties of these aldehydes. Now, as far as before going as far as the properties are concerned, you know that the properties are of two types. We have got physical properties as well as the chemical properties. Now, as far as the physical properties of these aldehydes are concerned, we see the lower member of this homologous series, that is a formaldehyde, is a it's a pungent smelling gas, whereas the other aldehydes and ketones containing carbon atoms up to the 11, they are colorless liquid. Whereas the members have higher members, that is having carbon atoms more than 11, they are solidus. Then we have got another this physical property, that is the smell. Now, as far as the smell is concerned, with the exception of the lower aldehydes, which have got a lower halide, which have got unpleasant odor. The higher aldehydes and ketones, they have generally a pleasant odor, or they have got a pleasant smell, or a fruity smell. Now, then we have got the solubility. Now, solubility, as you know, that these aldehydes and ketones, which have got carbon atoms up to 4, they are soluble in water. And this is due to the presence of hydrogen bonding between the polar carbonyl group and the water molecules. As I have shown, this is the carbonyl group here. It is polarized with a slight positive charge on this carbon atom, and a slight negative charge on the oxygen atom. As a result of this, this negatively charged this oxygen atom, it is attracted towards the positively charged hydrogen atom of the water molecule through hydrogen bonding. This is, you can see here, the hydrogen bond that exists between the oxygen of the carbonyl and this hydrogen of the water molecule. Now, this is because of its polarized nature of this carbonyl group. Now, with the increase in the size of this alkyl group, as I have told you that these aldehydes up to carbon number 4, they are soluble in water. But with the increase in the size of the alkyl group, the solubility, it generally it decreases, and the compounds with more than 4 carbon atoms, they are insoluble in water. Now, all aldehydes and ketones, however, they are readily soluble in organic solvents, like we have got ether, alcohol, we have got benzene, etc. However, now, as far as these ketones are concerned, they are used as they are good solvents. Now, these ketones are themselves, they are good solvents. Then we have got another this physical property, that is the boiling point. Now, the boiling point of aldehydes and ketones are higher than those of the hydrocarbons of comparable masses, but lower than those of the corresponding alcohols or carboxylic acids. This is because aldehydes and ketones are, they are polar compounds, because the carbonyl group, it is polarized, having they having sufficient this intermolecular dipole-dipole interactions between the opposite ends of the carbonyl, and that is oxygen and this oxygen, that is carbon and oxygen of this carbonyl group. However, these dipole-dipole interactions are weaker. These dipole-dipole interactions, they are weaker than the intermolecular hydrogen bonding in alcohols and carboxylic acids. Therefore, we can say the boiling points of aldehydes and these ketones, they are relatively lower than the alcohols and these carboxylic acids of comparable masses. You can see, I have shown here, this is pentane. It has got a molecular mass of this, it is 72. You have got this butanol, one butanol, it has got a mass of this molecular mass of 74. Then we have got butanol. This is an aldehyde, butanaldehyde. It is a molecular mass is 72. Then you have got ketone, this butanone, it's a ketone, so it is a molecular mass is 72. Now, if you look at the boiling points of these compounds, you can see the boiling point of this pentane, it is 309 Kelvin, while as the boiling point of butanol, it is 391 Kelvin. Then we have got butanol, its boiling point is 349 Kelvin. Then we have got this butanone, its boiling point is 353. So we see among these compounds, we see that it is that alcohols, they have have got relatively high boiling points, and I have told you the reason that it is due to the presence of hydrogen bonding that leads to molecular this association. So it is because of this reason that the boiling points of these alcohols are higher than the other compounds. Now, amongst themselves, we say that in case, amongst themselves, in case of that is in ketones, and in case of these carbonyl compounds, we have got ketones and we have got these aldehydes. Now, ketones have got a higher boiling points than those of isomeric aldehydes. This is due to the presence of we have got two electron releasing alkyl groups that are attached to the carbon of the carbonyl group in case of ketones, which make these ketones more polar. Now you can see here this is formaldehyde. It is this formaldehyde. It has got it is dipole moment. You can see it is here 2.27 dpi, whereas that of this acetone, in which we see the carbon is attached to the two methyl groups, it is this dipole moment is 288 d. So this is, that means this the carbonyl group in case of these ketones, it is relatively more polarized than in case of these aldehydes. Now then we have got the chemical properties. Now before going through the chemical properties of these aldehydes and ketones, let me give you an idea of the structure of this carbonyl group. Now as you know that both aldehydes and ketones, they contain this carbonyl group. We see that the carbon atom in this carbonyl group, we see it is in a state of sp2 hybridization. You can see this is the excited state configuration of carbon I have shown here. Now in this case we see that this hybridization, it takes place between 2s 2px and 2py. Now this 2pz of this carbon atom, atomic orbital of the carbon atom, it does not take part in hybridization and it remains unhybridization. So hybridization takes place between these three atomic orbitals, that is 2s1 2px1 and 2pz1, and we get a set of 3 sp2 hybrid orbitals which are directed in space towards the corners of a triangle at an angle of 120 degree. Now out of these 3 sp2 hybrid orbitals on the carbon of this carbonyl group, we see that two hybrid orbitals, they are involved in sigma bonding with the two carbon atoms of the two alkyl groups, or in case of this ketones and in aldehydes, they are involved in sigma overlapping with hydrogen atom and the carbon of the alkyl group. Now the third sp2 hybrid orbital of this carbon atom of this carbonyl group, it is involved in sigma bonding with the 2p with the 2py orbital of the oxygen atom, giving rise to another this sigma bond. So we have got 3 sigma bonds here. Now the 2pz, that is unhybridized orbital of this carbon of this carbonyl, and the 2pz of this oxygen atom, they are involved in a lateral overlapping, and they give rise to the formation of this of a pi bond. Now it is thus we can say that the carbonyl group, it is planar. It has got a planar structure. The unhybridized, as I have told you, p orbital of the carbonyl carbon forms pi bond with the oxygen atom by sidewise overlapping. Now we know that this oxygen atom in the carbonyl group, it is relatively more electronegative than oxygen, because its electronegativity is 3.5 in Pauling scale, whereas that electronegativity of carbon, it is 2.5. So as a result of this oxygen atom being more electronegative, it attracts the shear this pi electron share it attracts this electron cloud slightly towards itself, as a result of which this oxygen atom, it develops a slight negative charge, while as the carbon atom, it develops a slight positive, while the carbon atom, it develops a slight positive charge. Now now because of its polarized nature we see that this carbonyl group we see it shows resonance, it shows two canonical structures you can see here. Now this carbonyl this carbon of this carbonyl group, it is attacked by this by now it's attacked by the nucleophiles. Now this is unlike those of these alkenes where we see that that the ethylenic bond, there we see that that undergoes this electrophilic addition reaction, whereas this carbonyl carbonyl this group, in case of this aldehydes and ketones, it undergoes this nucleophilic addition reactions. And one more thing about this is that this is because this carbonyl group, it is polar in nature, whereas this ethylenic bond, it is non-polar. So this is about the structure of this carbonyl group. Now in our next lecture we will discuss the chemical properties of these carbonyl compounds. So this is for today. Thank you very much.